Welcome back to Creating Stuff. This is a great day today because I'm getting back on a project that's probably sat for the last 8 months. And that's right, Inferno. That's my Toyota truck I'm building. I started last year. I've been sharing everything with it on this channel on the build of this truck. So, and as the video I stated before, why I had to put it aside along with a lot of other things, including this YouTube channel. This truck sat for about 8 months. I hadn't touched it, hadn't done a single thing with it, and I have a ton of parts for it. This truck could be, man, if I had a little bit more time, so I really could get this truck going again. So, so where we're at right now is where we left off in Inferno. Is we more or less got the front end, suspension and steering together. So now the next step we need to do is we need to get the rear axle underneath it. So, and the rear axle I plan on using is a Dana 60 out of a 2002 2500 Dodge with a gasoline engine. So biggest reason I chose that axle, other than it was cheap, it was available, it had a couple very important things I wanted. Is number one, I really wanted to have a Dana 60 just because I have a 60 in the front, I have a 60 in the rear. Not that that matters, but is what it is. I wanted a Dana 60, I wanted disc brakes, and I wanted a parking brake. So I plan to make this truck street legal. You got to have a parking brake for that. You should have one anyways. So those are the things, the reason why that's why I wanted to use that axle. And now we're going to get to the subject of our video. Is the first step in putting that axle in the back, we have to change the bolt pattern. Is because the front axle I'm using is a 2006 F250 Dana 60, so found in the Super Duties. So it has an 8-on 170 millimeter bolt pattern. When I say bolt, well, that's a bolt circle, if you really want to call it that measurement is. But the rear axle has an 8-on 6.5 inch bolt pattern. They're different, they don't fit. So I got to make one match the other. Now, although I can already see the comments, is someone's going to say, well, they already sell the front hubs where they're already with the 8-on 6.5 bolt pattern. That's all well and good. I appreciate that, but I want the repairability, is meaning I can go to any auto parts store and buy those front hubs fully assembled, ready to go, that will bolt on that axle. That's what I want to keep. So the rear axle, they actually have serviceable wheel bearings. So I'm good changing the bolt pattern on that one, because guess what? If I have a wheel bearing failure, as long as it's not too bad, you know, I can knock those races out, put new races in, I can fix it, I put it back together. That's serviceable. The front hubs are a sealed unit, so that's why I'm changing the rear and not the front. So but it might limit me a little bit on wheels I can run, but I'll deal with that. So anyway, so the first step is we're going to have to convert the rear hubs to 8-on 170 millimeter bolt pattern. So well, we're not gonna be able to do it, so let's head on into the shop and let's get started with this. Now that we come into the shop, here's the rear hubs of that Dana 60 rear axle. Well, actually it's just one of them. So this is what we have to modify. And when I say 8-on 6.5 or 8-on 170 millimeter, basically when I say that, is really what I'm talking about is the 8 is I have 8 lug nut studs, and the 6.5 or the 170 millimeter, that is the bolt circle. That is the diameter of the circle from the center of this stud to the center of that stud. So we're going to use that information, and we're going to use Fusion 360 in order to make the tools we need to change this bolt pattern. And part of the reasons that this is actually going to work very well on these particular flange since we have no webbing on the backside of the flange, we have a nice surface so we can drill through, press studs in, and it's going to work great. So, and what the plan is, in order to do this, and keep in mind, there's many different ways you can do this. This is just the way that I'm going to choose. And hopefully it'll make sense when we move forward with this. But first and foremost is I'm going to get I'm going to draw everything up on CAD. We're going to make a template that is basically, we're going to simulate, this is the rotor that goes on it. We're going to simulate this diameter with these holes, so it'll drop onto this hub and center on the hub. And then then in between these holes, we're actually going to put our 8 on 170 millimeter bolt pattern, but we're going to put small 1/4 inch holes in it. And the reason we're going to do that is those little 1/4 inch holes are going to be used for a transfer punch, where we can drop this template on here. We're going to be able to put a center mark on where all the lugs holes are going to go, so we can drill them. So that's going to be the first step. And then we have to make some I'm going to have to make some tooling, some fixtures to make this easier to drill. You can drill them by hand, but I like using my drill press. I don't have a milling machine. It would be nice. So if you'd like to see me have a milling machine, please subscribe to my channel, tell everybody about it, and help me get some sponsors so I can get a milling machine and a few other tools in here, because I would love to have some. So, but once again, the purpose of my channel is not to make money. It's really to get the ideas out to you, maybe spark your imagination, your creativity for something that you're doing. So, so once again, so we're going to make that template. I'm actually going to draw it up on Fusion 360. I'll show you how to do that. And I'm going to send it off to Send Cut Send and have them cut it out, because they're going to be a little bit more precise than my plasma table. So, but anyways, so let's go ahead and take this over to the drill press, and I'm going to show you what I have in store, or what I have planned for my holding fixture. Alright, so what I have over here at my drill press is, this is not set up right, but you notice how it has a hole in the middle. What I'm going to do is, I'm going to have to make a couple of different pieces. Number one, I'm going to make a flange that bolts onto these bolt holes with a 1/2 inch hole in the center, so a piece of all thread can go through and go through down here, so I can have a nut on either side, so I can actually lock it down to the table solid, so it won't turn. And then after I drill a hole, I can loosen it and I can turn it, lock it back down. Then the other thing I'm going to do to help keep it centered, which is going to probably be overkill, is I'm going to 3D print basically a little adapter ring that's going to slide into here, and then index in here and in here. This will still keep this face right here, will still keep this perpendicular and keep it level on the table, but all that will do is keep it centered on there. We'll offset the table, and that should work out real well. So if this doesn't make a whole lot of sense, hope it's clear as mud. If not, when I get everything back to start getting stuff together, hopefully it'll make some sense. Well, let's get this back over to the bench. We got to start taking some measurements. Well, now that I got all the measurements taken, let's go jump on the computer and let's draw some stuff up on CAD. Let's go. Alright, I've come in from the shop. I've got all my measurements. I'm sitting in my nice comfortable office chair in my computer at my office. So now we're going to start designing some parts. And I'm going to show you first more or less on how to do the template I'm going to make to re-drill the hubs. And then some of the other stuff I'll probably just put you on a time lapse. But there are some a feature of Fusion I'd like to show off. So now this is going to be the template to re-drill the flange. So we're going to start with This is the bore size of it. Alright, that's the center hole of the rotor that will fit over the hub. And now we're going to do a construction line, and this is going to be for the oops, that's not 8.5, that's 6.5. That looks a little better. Alright, so this is the bolt circle for the Dodge bolt pattern. So now we're going to go all the way up here on this line, and we're going to do the lug holes, the holes for the lug nut studs. Alright, that's one. Now, to make the pattern easier, what we're going to do is we're going to go over here to the Create tab, Circular Pattern. Now we're going to pick the objects, meaning this is the sketch we're going to select. Now the center point, which is the center of our template. And now you see you have this box here. So you have other selections, but we're going to do the full circumference of this circle. So we need 8. So we just bump this up. Alright, there's our 8 lug nut holes. Those are the existing holes with the 8 on 6.5. So we're going to click OK, and now we have all the bolts. So now we're going to do the 170 millimeter bolt circle. So we're going to, just for visual sake, we're going to do another construction circle. And here's the neat thing about Fusion is, although you can see I'm in inches, I'm going to type in 170 millimeters, and there you go. And see, that is the difference between. Now you can see the difference on why one bolt pattern won't fit the other. They're not by much, but they just won't fit. So now, to use the transfer punch, we're going to use a 1/4 inch hole. So we're just going to pick a point on that outer circle, and we're going to make a 1/4 inch hole. So now now that we have that 1/4 inch hole, we're going to do the same thing. We're going to go to Create, Circular Pattern, Create Object, or Select Object, and then we're going to come up here, Select Center Point, the center of the circle. And now we're going to bump this up to 8 circles. Oops, we had we ended up there we go. I think I had the point selected and not the actual circle. Let me just start that over. There we go. So that looks better. So then we have that, and we click OK, and there's our holes that we can use for our transfer punch to mark the center of the hole. So now we got to finish out the flange, or not the flange, sorry, I'm thinking sheet metal, but so we'll go just an even 7.5. Alright, so now we have everything drawn, and now I'm going to convert this into an easy file, or it just makes it easier to see. I'm going to finish this, and hotkey extrude key, click there, and we're going to make this 1/4 inch thick, and there you have it. That is our template to drill a new bolt pattern in that hub. So now I'm going to take this, I'm going to upload this to Send Cut Send so I get this cut out. And I'm also going to use this template not only to re-drill the flange, I'm also going to use it to re-drill the rotors. But I'll get into that, how I'm going to use this for both. And this is actually going to be, I'm going to keep this as a tool, so at any time if I have to replace a rotor, I can easily re-drill the rotor and away I go. So anyways, alright, well, I'm going to put a time lapse. If you want to watch some of the other stuff I'm going to do, I'm going to keep recording. I'll do a time lapse on some of the other parts I make. So alright, I'll see you on the other side of it. Well, it's been a couple of days since I've worked on Inferno last. I have to work and do all the normal stuff. And you know what? I had a shipment notification that I had a package. So let's see what, oh, here it is. Let's see what this is. I always think it's funny how they put "do not bend" on this. It's 1/4-inch plate steel. It's not going to bend. Anybody like Sour Punch candies? Alright, these two parts look pretty good. Let's cut them out and see how they fit. Now, these parts look pretty good. Now, the only reason I sent this one out to get done is because I just don't have a 1/4-inch plate steel right now. And I didn't need it right then, so you know what? I just went ahead and ordered it. It doesn't matter. And the other one, this one, I wanted this one to be precise. These holes are nice and straight, 1/4-inch. My machine will cut very precise, but my actual plasma torch, especially on holes that small, it doesn't cut them quite straight. I want them nice and straight for what I was doing. Well, now we got to see how this fits on the actual hub itself. And this is another piece I made. I actually 3D printed this, and what this is meant to do is, which it fits nice down in here, is basically it aligns this, and then this small piece actually lines up on my drill press. So all this does, this has like no load on it. All this is going to do is just to keep this centered on the table of my drill press so I can drill it. Well, anyways, let's flip this over. Let's see how good my measurements turned out to be. Well, that's pretty darn good. The truth of it is, I might have to adjust that a little bit. It's a little bit on the tight side, but for the most part, it fits tight, and that's really what I'm looking for. And the whole idea is I'm going to use a transfer punch to go through these holes to actually mark this. And you know what, and I'll probably end up, there's a little bit of a lip on here, so I'm going to take that lip off, and that should drop on just about right. So tell you what, I gotta put my work clothes on, so I'll bring you back when I get my work clothes on and we start to mark this. Alright, we're back. I had to get a few things done. I got the burr taken off of this piece. It was equivalent of, I don't know if you can't see it on the camera, but it was for the lead-in for the laser cutter. Not a big deal. Took that off, and now that fits down on there quite nice. Now, on how we're going to mark the holes is basically going to use this. It's called a transfer punch. It was part of a larger set. I think I paid 26 bucks on Amazon for that. But if you look closely, this punch is actually meant for a 1/2 inch hole. This for a 1/4. Basically, the punch lines up on the hole, then you just tap it with a hammer, put some mark on it. But I'm going to put a few clamps, just a couple of vice grips on this, just to make sure this doesn't wiggle around on me. But as you can see, the punch actually fits quite nice right inside these holes, so that's going to work out real well. Hold on tight. All right, we got our clamps on, so now I'm just going to take our hammer and we're going to go around and put some marks. We just put marks all the way around. Yeah, that was a nice tight fit. All right, so now we're going to pull this off. All right, now I'm going to bring you in for a closer look. Now you can see right there, that's from the punch that I just used. It put a little mark right where all my holes have to be for the proper bolt circle and the proper pattern. So now that I got those marked, I'm not going to bore you. I'm going to go ahead and punch these studs out, and we're going to go to set this up in the drill press so we can start drilling this. I'll show you what the setup I got going on for that. So, all right, I'll see you over at the drill press. Okay, now we're over at the drill press. So now on to the next step. So in order to hold, I'm basically, some of the parts I've made is also so I can hold this hub in position on here. Because number one, it's going to turn. You put pressure, it's going to turn. It's going to flip to one side. So we got to lock that down. So what I'm going to how I'm going to do that is, first and foremost, I 3D printed this piece of plastic. It's going to fit tight there, and it fit good right there. And so all that plastic doing is keeping this hub, keeping it centered, just so we don't have to fight it nearly as much. So then next, we had this piece of metal that I had laser cut out. I'm only going to throw 2 bolts in there. That's all I need. When I designed the part and I cut it out, I did all the holes just because I could, because it was easy. But all this is because I'm going to put a piece of all thread through the bottom. It's going to come up here and it's going to lock it in place. So let me zip these down first. Alright, those are locked down. Now, this is a piece of all thread, and I'm going to stick this through the underside of the table of my drill press. All right. So now, actually I'm going to use the nut on the bottom. It's just a little easier to get to. All right. Then that right there locks it from rotating. I still got to lock the table, but now start drilling our holes. Now to drill these larger holes, I'm going to have to do it in a couple different steps. Like I said, that's just something, a lot of times the larger drill bits don't go all the way, or don't cut really well. So we're going to start with a small one. But what people don't realize, although we're in a drill press, is this can actually flex and bend, especially the small ones. So what we're going to do, we're going to use a center point drill bit to actually start all of our holes. So since this is not long like this, this won't flex. So when we place it on that mark, it's going to drill right where that mark is. So, so that's the reason why we're doing this. So we're gonna go. So I'm gonna go ahead, chuck this up. I'm gonna line it up, lock this table down, and we're gonna start drilling some holes. Or we're just going to drill the center point of them. Alright, we are back. Alright, now I'm set up with the final drill size. Now, the one thing I will caution you on doing something like this or anything is I always like to do it, although this is the right size bit I need, I always do a test. Is because basically this is my test hole and these studs have to be pressed in. So this smooth section, when you look at this stud, this smooth section right here is actually a tapered, and then this ridged area section is actually what locks in. So basically that tapered section goes in, so we're going to press those splines down into the hub. So that's a good fit. See, that's too big. That's no good right there, because the stud will spin instead of when you try to tighten the lug nuts up. So we got to press these into place. So once again, did a test hole. So now we're going to drill our first hole in our hub. Well, and there you have it. all my holes have been drilled. So now we're going to get this taken out of here. I'm going to drill the other one. I won't bore you with that. Now we're going to take this over to the press, and we're going to press the studs in. Alright, now we're over at the press, because we have to press the studs in these hubs. And now I'm going to show you a trick that I use to make this a lot easier. And then also this will do is hopefully show us that we got our bolt pattern right. Is what I do is I take an old rotor. I don't recommend using a new one. You could possibly warp it, even though I will say that's never happened to me. But anyways, I take an old rotor, and now this is not a rotor off of this axle. This is actually a rotor off of the front axle that I'm using, the forward axle, which has the correct bolt pattern. So put the rotor in here. We're going to put the hub face down. And start putting studs in. All right, all the studs are in there. So now let's start pressing them in. Alright, this is a Ford 8-on 170 millimeter bolt pattern. These are the rear two rollers for Inferno when I get to that point. Alright, well here comes the final test. Well, there you have it. It worked out. Everything worked out well. So all right, I got the axle back together. The first time, that is. I will have this apart again. So, like I said, if you saw how I put things together, if I didn't do it quite perfect, this is coming back apart again because I got to pull the differential apart to re-gear it and put the locker in it when I get to that point. But for right now, this just needs to roll. And although I put grease on these bearings are actually lubed by gear oil from the differential. But the reason I put grease in there is because this is going to be sitting for a while. I don't know when this truck is going to get moved enough to get the oil circulating out there. So I don't want anything to rust. So that's why I coated the inside of the hub, the bearings and the spindle, everything with grease. So, so hopefully I don't have any rust issues. But regardless, but not to worry, when this thing starts moving, the gear oil will flow out to the wheel end and it's going to dissolve all that grease. So that's not going to be an issue. But still, you always want, anytime you change the bearings on a full floating rear axle, you want to pre-lube them. Normally I just soak them in 90 weight, the gear oil I use in the differential, and that's sufficient. But you got to put something. Unfortunately, when I worked as a mechanic professionally, I had this other individual. I won't even describe that individual. He put the rear wheel bearings together dry and took it for a test drive and burned a spindle slam up. So I actually got to see something really cool. I actually got to see a vendor come in and literally take a oxyacetylene torch and cut the spindle off of that fire truck, and he machined out the center, slid a new spindle in, welded all back together. And so that was pretty impressive. That's pretty neat to watch. I really wish I could show you this show you that on this channel, but unfortunately the gentleman who did it, I looked him up recently and all I found was an obituary, so I'd have to find somebody else. But one quick thing, I'll point out, I did have an issue taking this apart on the subject of replacing a spindle. If you can see this is a lock nut. This is the original spindle nut, and unfortunately this is the good one. Even though I truly tore this thing up trying to get it out. Unfortunately, a lot of locking nuts tend to destroy the threads. I had a big problem on one side. I did not show it to you because I wasn't really proud of the repair I made. It works. It's gonna work. I'm very, but it looked ugly. It is not my best work, but I'm glad I got it done. My only other option was, the reason I looked the guy up, I was going to probably have to get a new spindle welded in, or I'd have to go find another axle. So anyways, I got to work, but the one thing I did do is I did convert this axle. I'm not using these lock nuts anymore. I put the old-fashioned, just basically 2 nuts with a tanged tab in the middle, keyed tanged tab in the middle. You fold the tabs over, it locks the nuts. This has been good since the dawn of time, so I'm happy to go back to it. So that's just a small side note. Sorry I didn't show you the catastrophe on the other side of this axle, but like I said, that was not some of my best work. I really didn't want to share that. So, but anyways, well, that's going to wrap it for this. Unfortunately, this axle is going to have to go back in storage because I'm not ready to hang it underneath the truck yet. And tell you the truth, I think the next big step I'm going to do for Inferno is I'm going to pull it back inside and pull the factory Toyota rear axle out in preparation to set this axle up with a 3-link suspension. So once again, this is really getting exciting. It's been a while since I worked on this truck, so I mean, I'm ready to go. So I'm going to leave it at that. So be creative.